Hi, and welcome back. Today I'd like to talk about controllers, which is a generic term, but when we talk about controllers, we're talking about an Arduino-based controller. This is a Node MCU 12E. so that's a lot of numbers, but it's an ESP8266 based system, if you will, a microprocessor. So let's see if I can get this a little bit closer. I don't know if you can tell or not. There's a little module here soldered to the bigger module, and that has some other external components like a voltage regulator and whatnot that takes the 5 volts that comes in from the USB micro connector, or um, you can feed it straight in from some of the pins here. Now this one I've modified to be a lighting controller in one of the passenger cars. So it has some, vector board with some copper tape, foil, trace. What would you call that? I don't know. Homemade printed circuit board, only it's not printed, it's handmade. This is the basis of all of our controllers, whether it's a lighting controller or a servo controller or a motor controller. And we call our motor controllers block controllers because the initial use, or at least the thought, was to use them to control the different DC blocks of the model railroad. And so, as far as controllers go, we get them 2 or 3 at a time. You can get them on eBay, you can get them on Amazon or AliExpress. They're just Node MCU modules. Let's see. Node MCU 1.0 is the 12E, and then I'm not sure what the 12F is. When I say 12F, well, here's what I mean. Here's a smaller version of, you can see there's that same Wi-Fi module that has really all the smarts built into it, and then this one is just enough extra. I believe that's the flash memory chip there, and I don't know if this one has a regulator on it or not. Pretty sure it's got some kind of 3.3 volt regulation for it. Is that built on the other side? Regardless, it's the same idea. You have a USB micro connection here to program it and power it, and then you can see it has all the plate throughs here for a set of header pins, like what's on there, that are already soldered into the 12Es. There we go. For power, if we want to power these battery powered, there are a number of different ways we can do that. Usually, like for a lighting controller, it's one of these 2,000 milliamp hour rechargeable lithium ion batteries. And for controllers, we have, well, here's a battery monitor circuit. Again, the familiar USB micro connector for power. And then you can see the connections here for a battery. This is a battery monitor, so one of the leads would connect to the battery and the other connect to the rest of the circuitry. So when I say power to the controller, this connector is where you would connect to the 2 leads that supply power to the controller. Now again, this battery monitor is better suited to applications where you would have a number of boost converters. Like say you needed 5 volts for the Arduino, you needed 12 volts for some other external like a servo motor or whatever the needs may be. That would be the best choice there. What I tend to use for most of the embedded stuff that is all 5 volts is one of these. Again, your familiar USB micro. And it has a USB-A connector for the power out, but what I do is I tap into the battery connection number 1. That's the familiar, I believe that's a JST. Is it a PH or an XH? I can't remember. I'll have to look that up, but that's what connects to the battery connection here. So, ooh, I feel like the weatherman sometimes when I'm looking in the monitor instead of looking at how it connects. But you can see there's a slot there, and then there's a raised rib on the connector here. So it's polarized, if you will, to where you can only connect it the correct way. Long story short, what we do is we connect the battery to it, and it has a bit of a what we'll call a boost converter. So you can see the controller chip there and a really small inductor. And if there are capacitors on there, it's a surface mount. In the light, it's hard to tell, but I mean, you can see that one little chip, something or other there. That might even be the LED. To get the power out of there, rather than have a huge USB cable connected to it, we just tap off of the leads on the back of the connector there. So let me see if I have another one here. Actually, I don't have one wired up, but this is how they come packaged. Usually there's 5 or 6 of these in a row, and you just snap the boards apart. There's when they make them to where it's got a little slit in there to where it makes it easy to snap it. But you can see all the connections on this side, for the battery, and then on this side you can see the connections on the back of that USB. The 4 on each one. So on this side is the power, and then the 2 signal lines, and then on the outside is the ground. And so on this one, it would be ground on this side, and it would be power on this side. But that's how we power that's how we battery power the controllers. All right, kind of got headed off down a rabbit hole there about specializing these controllers before I really talked more about what these controllers are. So this module here is, I don't know if you can see the little squiggly, yeah, you can see that, the Wi-Fi antenna. This is basically a Wi-Fi module that allows you to connect to any access point. And beyond that, this itself allows the controller to become its own access point, and it can do both at the same time. Not only can you connect to it with your Wi-Fi enabled device, it can connect to whatever Wi-Fi network you tell it. You just need to give it an SSID and a password, or the credentials for it, and it can connect there. In fact, what we do in the software is actually have a list of access points to connect to, and it will go through one at a time and try and continue to try until it can hit one of them. So once it's connected, then you have the ability to talk via a web server. That's the other nice thing about using these as the controller. They have a number of libraries available that let you create a web server, a web socket server, an access point. So all of the all of the code that you need to talk to wireless networks is built in. All of the code that you, well, I shouldn't say built in, but available for the built-in hardware. The web server is really nice, but what do you serve up? You serve up files. Well, where do those files live? This actually has a flash file system built in. It has flash memory, and you can store a good amount of information. Now, granted, nowhere near what you would store on a web server where you bought a domain and you have a service provider and you can put megabytes or gigabytes of information out there and have it served up as people want, as they click on your links, so to speak. Here we're limited. The flash itself is about 4 megabyte, and you can divide that up into a megabyte for code and 3 megabytes for data files, or 2 for code and 2 for files, or 3 for code and 1 for data files. What we do is divide it half and half, 2 and 2, and that's what we do. Maybe I'll pop up an image that we use for the passenger car lighting controller. But again, I want to stay out of the specialization that we do for all the different controllers. We'll have a separate content devoted to the lighting controllers, and perhaps even split that into passenger car lighting and building lighting controllers, as well as others that we haven't even thought of yet. We'll leave that up to you to ask, yeah, do we have that? Not yet. We can do that. And that's the beauty of these controllers. They're just that flexible. You're just writing code. You're writing an Arduino sketch is what it boils down to. So anybody that's done any of these IoT, Internet of Things projects, that's what we're using this for. Now, that's not to say that we're limited to these controllers. Let me see if I can find, hang on one second. Here's it's a Mega 2560. You can tell right there. See, it says it's 20. Anyway, this is Eligu. I think that's how you pronounce it. I don't know. It's all Chinese to me. So these allow you to, well, let me see if I can find one that's out of the package. I don't want to open the package. Back to controllers. What I'm looking for is a Mega, one of those Megas. Here we go. So, that's not the one I'm looking for either. Oh, for Pete's sake. I know I got one here somewhere. I bet I know. Oh, I almost narrowly averted disaster on that one. That's what happens when not all the cases fit evenly in there. So I think I showed this on a previous video, but these Megas, I actually have a new display panel on there, a 2.8, which is what, 50 by maybe 51 millimeters by, what is that, 2.8, it's almost, let's say 70 millimeter. But the nice thing there is you see how it has this, they call them hats, or some kind of we used to call them daughter cards, but you can see it has a number of pins on the display that fit right into the sockets on this Mega. So a Mega just has more, it has Mega IO versus an Uno has, well, if you can imagine just that much IO, where I've masked off the other connectors there, and Uno has about that much, the Mega has that much. And I will say that these little controllers here are limited to let's see, D0 through D8, and D8's kind of questionable, so let's say D0 through D7. That's 8 outputs. This alone has 56, gosh, 54, I can't remember. But just digital outputs, it has 16 analog to digital control inputs. It has power, ground, you name it. It has 2 SPI interfaces, which is the serial peripheral interconnect, not SPY but SPI. Um, and again, anyone that's used any of these IoT devices or any of these Arduinos are familiar with this. So here you have a USB B or a USB printer connector for power in and programming it. And then you have an external power jack that you can power it when you're not powering it through USB. And there are a number of other options, but you can see how big a power connection there is there. So you can control quite a few more devices with that. 50, would I say 50? So let's just say 50, and even 50 digital outputs compared to 8. So there's at least 6 times as many, going on 7 times as many. And you have 2, like I say, serial peripheral interconnects, one for stacking. That's what this one is for here, this connector. If you think about this daughter card arrangement, you can also have a connector here that would stack, and now you could put that many. The idea is you stack as many as you need, and then like in this case, if I had other hats that went on there, I'd put those on there first, and then they have another set of connectors for the next set of pins, and so on. So you just stack what you need. The daughter cards, stack them as high as what you need. And it, like with this display, I'd make this the last thing on the stack, obviously. Now you have to be careful, because as each one stacks up, sometimes they might steal signals or not, reshare that signal. As I was saying with the controller here, has a limited amount of flash. Well, here it has a SD card reader slot, so I think I have here, let's see, there's no thinking yet. It's a 32 gig SD card in there, so micro SD card. Hang on a second. Have to remember how this stacks on here. Let's see here. So when in doubt, look at the other one. Okay, so that looks right. Okay, so snap. So where was I going with all that? If we don't have enough I/O on the controller, on these little controllers, we can always talk to one of these huge I/O. If we're I/O bound on this, we can always go to a bigger and just use this for the Wi-Fi. In fact, we'd probably go to one of these 12F. I think it comes up as a WeMos or WiMos, however you pronounce that, D1, instead of the ESP8266. But in any case, what you have is the Wi-Fi, and that's what you're looking for. So you connect that to one of the more I/O, one of the mega I/O connectors. And then we have these other, let me see. Well, I'm not even going to go there. I have some smaller displays. Where I was going with all that was the fact that we have mega I/O available if necessary, and a number of other options for displays. So if you're not happy with these analog meters, if you're more of a digital guy, what can I say? I'm just old school. So let's see, what else do I need to tell you about controllers? Yes, we were going somewhere before I got totally distracted by mega I/O. Hang on, let me put some things away here. So yeah, the web interface, and I'll probably have to get to that in another chapter. So yeah, web server. This little guy is a really powerful piece of microcontrol equipment that lets you have a web server and let's say a modern user interface versus back in the day. And I'll stop there. We're going to wrap up this initial segment on controllers and point you at some more specialized information after this. Thanks for joining us. Thanks for watching, and we'll be back. Stay tuned. Subscribe, like, do as you wish.